Ozone layer, the Earth's sunscreen. Part 2 of 2. Solar UV radiation. The sun emits three main types of ultraviolet radiation. 1. UVC, 100 to 280 nanometers. 2. UVB, 280 to 315 nanometers. 3. UVA, 315 to 400 nanometers. UVC radiation is extremely damaging to humans and other life forms, however, it is entirely absorbed within the ozone layer. UVB radiation emitted by the sun is mostly absorbed by the ozone layer, the rest reaches Earth's surface. In humans, increased exposure to UVB radiation raises the risks of skin cancer and cataracts, and suppresses the immune system. Excessive UVB exposure also can damage terrestrial plant life, including agricultural crops, single-celled organisms, and aquatic ecosystems. UVA, visible light, and other solar radiation are only weakly absorbed by the ozone layer. Exposure to UVA is associated with premature aging of the skin and some skin cancers. UV protection by ozone. Ozone absorbs the most energetic wavelengths of ultraviolet light, known as UVC and UVB, wavelengths that harm living things. Oxygen molecules absorb other forms of ultraviolet light, too. Together, ozone and oxygen molecules are able to absorb 95 to 99.9% of the ultraviolet radiation that gets to our planet. When UV light is absorbed by oxygen and ozone, heat is generated, which is why the stratosphere gets warmer with altitude. UVC is completely absorbed by the ozone layer and atmosphere. UVB is mostly absorbed by the ozone layer. UVA is weakly absorbed by the ozone layer. It is remarkable that a layer of pure ozone only 3 mm thick, which is about the height of a stack of 2 common coins, protects life on Earth's surface from most of the harmful UV radiation emitted by the sun. Bad and good ozone. Ozone in the stratosphere absorbs a large part of the sun's biologically harmful ultraviolet radiation. Stratospheric ozone is considered good ozone because of this beneficial role. Although the troposphere extends up to around 15 kilometers, most tropospheric ozone is in the lowest 2 to 3 kilometers, it is sometimes referred to as surface ozone. Ozone formed at Earth's surface in excess of natural amounts is considered bad ozone because this gas is harmful to humans, plants, and animals. Ozone hole. Each year for the past few decades during the southern hemisphere spring, chemical reactions involving chlorine, bromine, and other ozone-depleting substances, ODS, cause ozone in the southern polar region to be destroyed rapidly and severely. This depleted region is known as the ozone hole, or more accurately ozone thin layer. The term ozone hole came about as a description of the very low values of total ozone, apparent in satellite images, that extend over the Antarctic continent for many weeks each October, spring in the southern hemisphere. The false color view of total ozone over the Antarctic pole. The purple and blue colors are where there is the least ozone, and the yellows and reds are where there is more ozone. The white thick line is 220 Dobson units. The baseline value of 220 Dobson units for ozone was chosen as the starting point for observations of the Antarctic ozone hole, since values of less than 220 Dobson units were not found before 1979. Also, from direct measurements over Antarctica, a column ozone level of less than 220 Dobson units is a result of the ozone loss from chlorine and bromine compounds. A thinning of the ozone layer also has been observed over other regions of the globe, such as the Arctic and northern and southern mid-latitudes. Long-term changes in Antarctic total ozone are demonstrated with this series of total ozone maps derived from satellite observations. Each map is an average during October, the month of maximum ozone depletion over Antarctica. In the 1970s, an ozone hole, as defined by a significant region with total ozone values less than 220 Dobson units, thick white line, was not observed. The ozone hole initially appeared in the early 1980s and increased in size until the early 1990s. A large ozone hole has occurred each year since the mid-1980s. There are emerging indications that the size and maximum ozone depletion, severity, of the Antarctic ozone hole has diminished since 2000. The return of Antarctic total ozone to 1980 values is not expected to occur until the mid-2060s. Trend. The minimum of Southern Hemisphere mean ozone for September 21 to 16 October for each year. 220 DU, baseline. 1979, 225 DU. 1994, 92.3 DU. 2006, 98.4 DU. 2023, 115.2 DU. 1987, Montreal Protocol, adopted September 16. As a result of global action through the Montreal Protocol, the ozone layer is expected to return to pre-1980 levels by mid-century, circa 2060.